Hello everyone and welcome to Prosper India. I'm your host and news analyst Nishtha. Why does a single heat wave in Europe sometimes last for weeks while nearby regions get non-stop rains or storms at the same time? It is not random. It is a pattern in the upper atmosphere called an omega block. And once it forms, it doesn't just change weather, it locks it in a place. What is an omega block? An omega block is a large-scale distortion in the jet stream, which is a fast-moving river of air high in the atmosphere. Normally, the jet stream flows smoothly west to east, constantly moving weather systems. But sometimes it bends into a stable pattern shaped like the Greek letter omega. That shapes form three main parts: a high pressure system in the center, two low pressure system on both the sides. So the structures look like this: low pressure, high pressure and again low pressure. This creates what meteorologists describe as a blocked atmosphere pattern. Now what does it do to the weather? An omega block doesn't create weather on its own. Instead, it stops weathers from forming normally. In the high pressure center, clear skies, strong solar heat wave that persists for 7 to 20 days, very little or no rainfall. In the low pressure zones, it is continuous rainfall, storm system repeatedly hitting the same region, flood risk increases over time. So instead of weather changing every few days, it becomes stuck in an extreme state. Now, why is Europe especially vulnerable? Europe sits directly under the path of the Atlantic jet stream. When an omega block forms over Europe, Western Europe can experience prolonged heat waves. Central Europe can remain locked in dry conditions, and surrounding regions may face persistent rainfall or storms. This is why major events like the 2018 European heat wave, the 2022 UK 40 degrees Celsius record, and the repeated Southern Europe droughts lasted far longer than typical weather conditions. Now you must be wondering that why does an omega block form? This isn't just one single cause, but scientists identify a few key drivers. Slowing jet streams, the temperature difference between the Arctic and mid-latitudes is shrinking. That reduces the speed of the jet stream. And the second is that amplified atmospheric waves. Now what does it mean? That the jet stream develops large undulating waves called Rossby waves. Instead of moving forward, these waves can become amplified and stationary. The third is climate influence. Research from IPCC reports suggests that a warming Arctic may increase the likelihood of persistent blocking patterns. This leads to weather systems that stay longer in one place. Now, why does it matter? The danger of an omega block is not just intensity, it's its duration. A normal heat wave might last a few days. An omega block can extend it to 10 days, 2 weeks, and sometimes even longer than that. And that duration creates compounding effects: heat stress on population, increased wildfire risk, agricultural damage, energy grid pressure due to the cooling demand. It's not just extreme weather, it's extreme weather that refuses to move on. A simple way to understand it is, think of atmosphere like traffic. Normal jet stream is flowing highway and omega block is massive traffic jam. When weather system enters and gets stuck in one place, no reset, no movement, no relief. Omega block shows that climate risk is not only about rising temperatures, it's also about persistence. A changing atmosphere doesn't just make weather more extreme, it can make it more repetitive and long lasting in the same region. And that shift is what turns ordinary seasonal pattern into prolonged climate stress events that reshape agriculture, energy demands, and daily life across entire regions.